In continuation to electrochemistry, the previous topic, in the previous lecture, I was talking about the difference between electrochemical cell and electrolytic cell I was talking about. And in this lecture, I would like to explain about the galvanic cell or electrochemical cell. So this lecture particularly discussing about electrochemical cells or galvanic cells. Sometimes we get confusion between this galvanic cell. What is a galvanic cell and what is a Daniel cell? Let me clarify the differences between what is the Daniel cell and what is galvanic cell. Daniel cell, there is no much difference between Daniel cell and the galvanic cell. Daniel cell is the galvanic cell in which the chemical energy liberated during the spontaneous redox reaction converted into electrical energy. So which is that electrical potential equal to 1.1 V when the concentration of zinc and cupric ions is equal to 1 unit per mole dm³. In Daniel cell, Daniel cell is nothing but galvanic cell. If we take electrode, anode as a zinc, cathode as the copper. A special galvanic cell in which zinc is taken as an anode and the copper taken as a cathode in their respective half cells. Then it is said to be Daniel cell. But in case of the galvanic cell, the electrodes, anode and cathode taken from different. Means anode should not be the zinc and the cathode should not be the copper. You can take any metal. So electrodes must be different. It should not be the same. But in case of the Daniel cell, electrodes are specified. Anode should be the zinc, cathode should be the copper. So that is the difference between the Daniel cell and the galvanic cell, we say. But in both cases, what happens? In both cases, the chemical energy is converted into electrical energy. So how the electrical energy generated? So in galvanic cell or in the Voltaic cell, sometimes the galvanic cell is also said to be Voltaic cell. So based on the scientist name, Alessandro Volta. Okay, let us discuss so the construction of the galvanic cell, so in which the chemical energy is converted into electrical energy. A typical galvanic cell is built with two half cells. A typical galvanic cell, look at this picture. A typical galvanic cell is built with two half cells. One is taken left side, other is taken right side. The half cell is taken left side should be anode in which oxidation takes place. The another half cell which is taken right side, so in which the reduction takes place. A typical galvanic cell, look at this picture. In this left hand side, there is one half cell is taken. And in this half cell, for example, electrode, anode, zinc is taken as an anode, and this zinc metal strip is placed. The zinc metal strip is placed where in zinc sulfate solution. The electrolyte solution taken in the device in the half cell is zinc sulfate solution, and in this zinc sulfate solution, so zinc metal strip is placed. Zinc metal strip is placed in the zinc sulfate solution, which act as a So oxidation half cell, which is taken left side of the galvanic cell. And in the right side, if you observe, so in the half cell, reduction half cell, there is a copper sulfate solution, electrolyte solution is taken, and in this, a copper metal strip is immersed. A copper metal strip is immersed in the another half cell, which is taken the right side, where the reduction half cell we say. And both are connected. The zinc anode, zinc metal is connected to the copper by voltmeter, high resistant voltmeter. The deflection of the voltmeter will indicate that, so how much current is passing through that. When the zinc metal is taken in the zinc sulfate solution, the copper metal is taken in the copper sulfate solution. And both half cells are connected by, there is a salt bridge, a glass tube. Thin glass tube is U-shaped glass tube inverted or so kept between the two half cells. It is the salt bridge will be connecting these two half cells. But what components are present in this salt bridge? So how it can connect to the two half cells? What is the function of this salt bridge? So what components are present in the salt bridge? A salt bridge is a glass tube and it has opened both sides. Two ends are open and this glass tube is stuffed with agar gel. So which is immersed in the what we say sodium chloride solution or potassium chloride solution or potassium nitrate solution. So with the required concentration of sodium chloride solution or potassium chloride solution, it is stuffed with that agar gel, and so the main function of the salt bridge between the two half cell is that it can maintain electrical neutrality. So the salt bridge only permeable for the ions, So and the salt bridge permit the ions, so entering into the two half cells. So the main important function of the salt bridge is that to maintain electrical neutrality, it can maintain. So and it can allow that permeability of the ions. So whenever the zinc ions number increases or cupric ions number decreases, so balancing that number of ions with the cations and anions, the salt bridge will furnish. So the salt bridge is the connector between the two half cells and making the two half cells complete cell, we say. And so the anode is connected to the cathode by using the wire through the voltmeter, high resistant voltmeter. When we connect the zinc anode to the cathode through the voltmeter, so when the salt bridge is connecting between the two half cells, the circuit is completely made. Then, so the zinc which is placed in the zinc sulfate solution undergoes oxidation. So between the zinc and the copper, there is a potential difference is generated. When the potential difference is generated, then zinc undergoes oxidation. The metal ions present in the zinc undergoes oxidation and loses electrons. That electrons passes into the wire. And the zinc metal atoms, after undergoing oxidation, zinc metal ions fall into the solution. That means in the electrolytic solution, the concentration of zinc plus 2 ions number increases as the electron passing through the circuit. When the electrons are passing through the circuit, here you can see the equation, zinc metal gives rise to Zn plus and 2 electrons. That electron passing into where means into the voltmeter. Then the voltmeter will show the deflection. So since the anode, the electrons are, so electrons, when the zinc metal undergoes oxidation, the electrons left, those electrons will be passing through the, so metal, zinc metal, hence the anode is represented with the cathode. Anode is represented with the negative charge. Negative charge. Here anode is represented with the negative charge. The sign of convention is negative here. So after some time, what we could notice is that zinc ions number in the solution increases. When the positive charge in the solution increases, so the negative ions from the salt bridge like chloride ion or nitrate ion, the chloride ions will move into the into the electrolyte solution. Then it can form that zinc chloride or zinc nitrate. As the zinc undergoes oxidation, the electrons from this wire passing in this direction towards the cathode, the electrons moves, then the voltmeter will show the reading deflection it can show. And the electrons captured by the cathode here, so then the cathode is the source of so positive charge, source of electrons we say here. The sign of convention for the cathode is internally positive. Positive we can write. The sign of cathode is a positive internally because once the cathode receives the electrons given to the cupric ions present, in the electrolyte solution, the cupric ions gain 2 electrons from the cathode, and copper is deposited over the surface of this cathode. The copper metal is deposited. Since the cathode loses the electrons, then the cathode gain the positive charge. In typical galvanic cell, so anode carries the negative charge and the cathode carries the positive charge. Sign of convention. So when the cupric ions get reduction, the copper is deposited over the surface of the cathode. The number of cupric ions decreases, then sulfate ions number increases. Since the number of negative charge increases, the negative charge increases in the solution, hence the salt bridge come into the role. The salt bridge will be releasing positive ions into the solution, like sodium or potassium ions. So potassium ions or sodium ions are falling into into the electrolyte solution, and in order to balance the negative charge. So in the right side, positive ions comes into the role for the balancing of the negative charge. The left side, so negative ions balancing the positive ions. As a result of this, electrical neutrality is maintained. As the time progresses, what happens? Electrons moves towards the cathode, and positive charge moves towards anode. The positive charge will be moving towards anode. So across the zinc and the copper, the cell potential, so the reduction potential difference between the two electrodes, which is equal to how much? 1.1 V volts. If we take 1 mole per dm cube of the solution, the concentration of the solution, if we take the voltage value, cell potential of the galvanic cell is equal to 1.1 V volt. If we take the concentration of the solution is 1 mole per 1 dm cube, so with the concentration, then the galvanic cell voltage will be 1.1 V. So, but if we apply as the time progresses, the cell potential increases 1.1 V. So, and the voltage increases. Or if we apply external voltage, more than this 1.1 V, what happened to this galvanic cell? When the external voltage is applied more than 1.1 V voltage, initially the cell reaction continues, but as the voltage exceeds more than 1.1 V, the cell reaction, the electrons movement from left to right will stop, and the cell external voltage increases more than 1.1 V, the cell working will stop and it behave like electrolytic cell. That means when the external voltage exceeds more than 1.1 V or external batteries applied over this on this galvanic cell. So what happened means then electrons stop moving and the galvanic cell itself changes into electrolytic cell. Then the electrons moving towards the anode will take place and the charge movement will be taking place towards the right, opposite. Let us discuss so what happened when external voltage is less than 1.1 V. When external voltage is less than 1.1 V, so it remain like electrochemical cell. It remain like a galvanic cell only. Since the electrons flow from zinc to copper will takes place, and the zinc dissolves at the anode and the copper deposits at the cathode. So it is a purely galvanic cell, we say. In the second case, what happened? The external voltage when we apply, which is equivalent to 1.1 V. So by apply through the external battery and by connecting to the rheostat. So here what happened means when the external voltage is equal to 1.1 V, no flow of electron takes place and no current passes in the circuit, no chemical reaction takes place. So when the external voltage equivalent to 1.1 V. In the third case, what happened? External battery is applied. So the external voltage exceeds more than 1.1 V. The electrons flow from copper to the current flows from zinc to copper. And zinc is deposited the zinc electrode, copper dissolves in the copper electrodes. So the electrons movement will be reversed, we can say. If the external battery is applied, external voltage applied more than 1.1 for the galvanic cell, then electrons means the galvanic cell itself becomes into electrolytic cell, we say. If the external voltage exceeds more than 1.1 V, the electrons movement takes place from cathode to anode. So that means the galvanic cell is a electrochemical cell. So produces that cell potential equivalent to 1.1 volt. That means the cell potential is the difference between the difference in the reduction potentials of zinc and copper. The cell potential of the galvanic cell potential is equivalent to how much? 1.1 V is the difference between the reduction potentials of zinc and the copper when both electrodes are connected through the circuit. So this is about the galvanic cell construction, and so in this galvanic cell, the major principle is that chemical energy generated during the spontaneous reaction, redox reaction of when the zinc metal is placed